There's one final force-related concept, and that's the concept of net forces. And what the concept of net forces say is once you add all of the forces on an object together, you can just treat that object as if it has one force acting on it, the net force. And that's a little easier to understand if we have an example. So let's go back to our rock sitting on a hill. If there's no forces acting on the rock, which is a little unrealistic because there has to be at least gravity, then we have a net force of 0. But if we add in gravity and the normal force, the pushing up force, and they exactly cancel, so it's not going up or down, we can describe it as having a net force, which we once again write using sigma, of 0. And this means it behaves exactly identical to some magic rock that isn't affected by gravity, that just sits here with no forces on it at all. And going to a slightly more complex case, let's say we have the rock with someone pushing on it. No matter how many competing forces there are on it, once we add them together, we can treat it as if there's one force. So let's say in this case, there's someone pushing on the rock and they're exerting a force this way, and there's a force of friction this way, and gravity's down, and the normal force is up. And then let's add more strangeness. Then let's say a much smaller person is pushing in this direction, which means that he's exerting a force in this direction. We can add all of these different forces together. We can say we have one force going this way. That's the force of push 2. We have the force of friction, the force of push 1, force of gravity, and the force of normal. And then we can start adding them together. And we add the x terms together and the y terms together. So force of normal and force of gravity are both in the same direction. And because it's not speeding up or slowing down, we know that the net force in the y direction has to be equal 0. So force of normal plus force of gravity equals sum of forces in the y direction equals 0. And then let's say we add together force of push 1 plus force of push 2 plus force of push 3 equals, let's say, negative 10 newtons. It's 10 newtons pointing in the backwards direction, so that direction. And we know that's the sum of forces in the x direction. So because of this rock, even though there's 5 or 6 different forces acting on it, it behaves exactly the same as a rock that's floating in outer space with one force that's pointing in the negative direction with 10 newtons. What this means is, in very complicated situations, where there's lots of forces and it's hard to imagine what they're all doing, we can simplify it down to one very simple force, and then do our problem from there. So we've touched on the idea of a free body diagram, but now we are missing one important concept there that we can add here. When drawing a free body diagram, first you draw all the objects you're dealing with, so our rock, and then you draw all the forces, so you can draw the different forces acting on it, and then you have to write what the net force is. And you either have to think of the net force as the sum of forces, or the net force is 0. And you know this depending on the problem. If the object isn't accelerating, it's staying still, or it's going at some constant speed like a car on a highway, then we know the net force equals 0. And that means that even if we don't know some of the forces, we know they all cancel unless we can figure it out. On the other hand, sometimes we actually have a net force that's the sum of forces, where we know all of the forces, but we don't know what the net force is. And then you could figure it out that way. So you'll see different types of problems asking you to do different things in different ways. But the most important thing is you start with a free body diagram, you draw your object, you draw all the forces acting on it, and then you decide whether your net force is 0 or the sum of forces. I'll give you some problems to work on for this one, and then the next set of lectures we'll talk about Newton's laws and how they can tell us even more about forces.